In this video, we're going to be graphing logarithmic functions. So if we have a function f of x equals log base b of x, then the domain is going to be the set of all positive real numbers, and the range is going to be all real numbers. There's not going to be a y-intercept, and the x-intercept is going to be at 1, 0, and then it's going to contain the points 1 over b, negative 1, 1, 0, and b, 1. So let's recap real quick. Back when we did exponential functions, remember with an exponential function, we had the domain was negative infinity to infinity, so all reals, and the range was a set of all positive real numbers. Notice that with the log, it's the opposite. The domain is all positive real numbers, and the range is everything. With an exponential function, so again, an exponential function is b to the x, where b is a positive real number that's not equal to 0 or not equal to 1. We had the y-intercept at 0, 1. Notice with a log, we have an x-intercept at 1, 0. And exponential function contains the 3 points, negative 1, 1 over b, 0, 1, and 1, b. Notice that in our logarithmic function, we have changed the x and y coordinates. So the domain has flip-flopped, the intercepts have flip-flopped, and the main three kind of common points have flip-flopped. The x and y's have been interchanged. That's because exponentials and logarithms are inverse functions. They're inverses of each other. And another important thing about a log is because the domain is a set of all positive real numbers, we cannot take the log of a negative number. It won't work. If you try to type it into your calculator, it'll say error. Okay, you can't do it. You can only take the log of positive real numbers. So when we graph a log, such as f of x equals log base 3 of x, the first thing we're going to do is rewrite it exponentially. Okay, so we're going to replace f of x with y, right? F of x is the same thing as y. And then rewrite it exponentially. So log base 3, the base is going to be 3 in our exponential. Logs equal exponents. So the exponent to this exponential is y, and that will equal, the only thing we haven't used is the x. The reason we're going to do that is because we're going to plug in y values, and it's going to get out x values. If I try to plug in x values here, for one thing, my calculator doesn't have base 3. It only has base 10 and base e. So some calculators won't even let you calculate that, and if I plug in just random numbers for x, I'm going to get out lots of decimals, versus I want to graph whole numbers. So if we rewrite it exponentially, we can get those nice whole numbers. So now we're going to pick values for y, find x. Again, the opposite of what we would do with an exponential. An exponential, we would pick the x values, solve for y. Here we're picking the y values, solving for x. So let's go ahead and do that. I have picked some points here for us, negative 2, negative 1, 0, 1, and 2. Let's plug those in. 3 to the negative 2 power is 1 over 3 squared, right? The negative takes the reciprocal. That's 1 over 9. So you get 1/9. Then if I do 3 to the negative first power, again takes the reciprocal, and to the first power is just 1/3. 3 to the 0 is 1. Anything to the 0 power is 1. 3 to the first power is 3. And 3 squared is 9. Notice that these are just like the points we found before. If we go way back to our exponentials, we graphed 3 to the x power. We had those same points, except for now the x's and y's have interchanged. So here I started with these values and I got out the y values. Now I'm starting with the same values I started with the exponential, but now I'm plugging it into y, and I'm getting out the same values that I did with the exponential, but now these are the x values. So let's go ahead and graph it. 1/9 negative 2, so it's close to the y-axis, but not touching it. Then 1/3 negative 1. Again, close, but not touching it. 1, 0. 3, positive 1. And 9, 2. So, as we mentioned before, the domain is all positive real numbers, so it's going to get close to this y-axis, but it's not going to cross it because I can't input a negative number for x. So it's not going to go into the negative x values because I can't, it's not part of my domain. And there you go. So log base 3 of x looks like this. And remember our exponential, so this one was log base 3 of x. Our exponential looked like this. And that is 3 to the x power. Notice that they are mirror images across the line y equals x. Because, again, they're inverse functions of each other. Alright, why don't you try this example and see how you do. Alright, the first thing I'm going to do is replace g of x with a y, because g of x is the same thing as y. And then I'm going to rewrite it exponentially. So the base, it's log base 1/3. The base is 1/3. Logs equal exponents, so the exponent is y, and that will equal x. So now I can plug in my y values and solve for my x values. So 1/3 to the negative 2 power takes the reciprocal, so it becomes 3 to the 2 power, and 3 squared is 9. And 1/3 of the negative first power takes the reciprocal, and that is just 3. 1/3 to the 0 power is just 1. Anything to the 0 power is 1. Anything to the first power is itself. And when we square 1/3, we get 1/9. And we can go ahead and graph that. So now we have positive 9, negative 2. Positive 3, negative 1. 1, 0. And 1/3 positive 1. And 1/9 positive 2. So again, this is going to be close to that y-axis, not crossing it, and going that way. And remember when we had a fractional base with our exponential functions, instead of going up like a base that was greater than 1, it is coming down. So the exponential function with a fractional base went like that. So again, still a mirror image of the other function. Maybe this would be better to see if I did it in a different color. So let's do this color. This one is the exponential function. And there you go. So logs and exponential functions are inverses of each other. In general, if we have an exponential function where the base is bigger than 1, it'll be going up from left to right, like that. If it is a fraction, so it's between 0 and 1, it'll be coming down from left to right. And if we have a logarithmic function where the base is greater than 1, it will have this general form coming up from left to right. And if it's between 0 and 1, so a fraction, it'll be coming down from left to right. And that's the general, so without any shifts or anything, that's what's going to happen. So let's look at one that does have a shift here. So if you look at this, we have a value in here inside with the x. Based on previous examples, you might guess which way this is going to shift. Let's go ahead and try it. So again, I'm going to replace this with y equals log base 2 of x plus 3. Then I'm going to rewrite it exponentially. It was log base 2, so the base is 2. Logs equal exponents, so the exponent is y, and that equals what we took the log of, x plus 3. I'm going to subtract 3 from both sides and get 2 to the y minus 3 equals x. Now I can start finding points for my table. Remember, we are going to plug in values for y and get out x values. So I'm going to choose some y values. Thinking about this exponent, I'm going to start with just like 0 in the middle and then pick some on either side of that. And so those are my points, my starting points. So if I plug in 2 to the negative 2 minus 3, 2 to the negative 2 power, the negative takes the reciprocal and the 2 squares it, so I'll end up with 1/4 minus 3 would be negative 2.75. And then if I plug in negative 1, I would get the reciprocal of 2 would be 1/2 minus 3 would be negative 2.5. Plugging in 0, 2 to the 0 power is 1. 1 minus 3 is negative 2. 2 to the first power, that would be 2 minus 3 would be negative 1. And 2 squared, 2 squared is 4 minus 3 would be positive 1. And then I'm going to go ahead and do one more here. 2 cubed minus 3 would be 8 minus 3, which is 5. Alright, so I had negative 2.75, negative 2.5, negative 2, negative 1, 1, and 5. Let's go ahead and plot those. So now I have negative 2.75 on the x-axis and negative 2 on the y. Then negative 2.5, negative 1. and then negative 2, 0, negative 1, 1, 1, positive 2, and 5, positive 3. So it looks like it's going to keep getting closer and closer to negative 2, but never cross that. And like such. So it still has our log shape here, but it has shifted, right? So we thought that it should go through 1, 0 here, but that point has moved back 3 places. So this positive 3 inside shifts it left, so shifts it in the negative 3 direction, so going left 3. So there's an example of a shift with the x value. In general, this is the process for graphing a log. We replace the function notation with y, we write it exponentially, pick some y values, solve for the x values. It's very easy to do the first few steps and then still write these values in the x column. So just be careful. You are choosing y and solving for x.